Hello and welcome to the Siemens Global University Challenge 2018.
Hi, I'm studying Masters in Management and Engineering with specialization in Technology, Innovation, Marketing and Entrepreneurship at RWTH Aachen University.
I'm Suraj. I'm doing my Masters in Management and Engineering with a specialization in Computer-Aided Mechanical Engineering at RWTH Aachen University. Let us now go and have a look at our idea.
To know our idea better, we need to realize our pain point. So the pain point here is that after the machining process, inspection and comparing the physical component against the 2D technical drawings or the 3D CAD model is at the heart of the quality checking processes. And all of it requires an operator who handles this inspection process. He may be using measuring devices or visually inspecting or maybe using a 3 cm scan. But our approach here is that since we are generating so much data, we can use this data using analytical tools to inspect the quality of the machine component and avoiding the above step. Our use case, we used MATLAB and Siemens 11 right now, but maybe later in the stage when it comes to developing the product, we would be using Python and JavaScript. Our approach for this idea involves 6 steps, starting with the acquisition of data, where we obtain the data from the decentralized periphery, such as the MindSphere or even the machine directly. The second would be giving a straight structure to the data, which is data parsing. The third would be filtering the data, which is extracting only the relevant data that we need. The fourth one would be to choose the right mathematical model or visual model for our data. For example, in this presentation, we used a scatter plot. The fifth would be to verify once we have the machine data plotted, we can compare it with the CAD plot or the CAD blueprint that we have and verify if the machine data is falling within the tolerance or not. And sixth would be to validate it. So once the verification has happened, we have to verify all the previous 5 steps for n number of different data sets so that we can validate the whole script or our approach for further use. To understand the idea better, let us take this dummy example where we have created a dummy part model on NX and have made the points on the curved surface of the model that we are using. And then we use a grip file to extract all those points and export it into a .data file, which can then be used directly on MATLAB or any other software. So as you can see on the left hand side, we have the data file that we generated in the previous step from Siemens NX software. And on the right hand side, you see some data which is acquired directly from the machine. For example, this data was in TDMS format that we are using. Now using MATLAB, we plotted the data that we saw in the previous slide, and we used a scatter plot. So as you can see on the slide, the right hand side, the blue data points, they are the CAD points or the data points that we picked from NX CAD. And on the left hand side are the data points that we got from the machine directly. And as you can see, there's a variation in the two data, which is because of NX uses a different coordinate system, and for the machine, the coordinate system could be different. So our approach is now to align the two data sets into the same scale so that we can see if they are matching or is there an aberration in the data. Now we scale the data using our scaling script. So both the data are now scaled to a common scale, and we can observe that there is no aberration since the data sets are overlapping each other, which ascertains the fact that the machined components is falling in the tolerances as specified in the blueprint or in the CAD design. And this is how we can avoid using or going for a physical inspection of the machine component.